The adrenal glands are also known as the suprarenal glands because they are located above the kidney, superior to the kidney, kind of like a kidney hat. They're actually pyramid shaped in a three-dimensional or three dimensions, but they appear triangular in a two-dimensional view like this. These glands, they also lie within the protective capsule of the kidney, and they don't have any separation from the kidney itself, which is strange. Why would you want to be exposed to all of the toxins that are in the kidney? The adrenal gland consists of the outer cortex, which I'm unfortunately highlighting in yellow, and it is yellow there. And the cortex is made of fats and other cortisol and cholesterol based substances. And then there's an inner medulla, which appears to be full of these neurosecretory axons, very similar to the ones that are in the posterior pituitary gland. The cortex usually has like a striped appearance to it, whereas the medulla is really rich in blood vessels and looks like neurons. The hypothalamus connects directly to the adrenal medulla through neurons. The cortex has three zones. From superficial to deep, these zones are the glomerulosa, fasciculata, and reticularis. The word glomerulosa means little spheres, and the histology of this outermost layer of the cortex has this appearance of little spheres, and you can see some of those here and here. The zona fasciculata is named for its ribbon-like appearance. That's what fasciculus means. And this zone, it's the largest of the zones of the cortex, and it accounts for the bulk of the cortex. The histology shows you these nice cords that you can see kind of running along on the zona fasciculata. The zona reticularis is the innermost zone of the cortex, and it is just superficial to the adrenal medulla, which is, it's kind of like a really separate organ from the cortex. The word reticular, it's a common word that we will see a lot with many applications to histology, organs, and structures that have a network or a web-like appearance. In truth, this network or web-like appearance in the adrenal cortex, it can be obscured by the plane along which the adrenal cortex is cut. The outermost layer, or the zona glomerulosa, produces mineralocorticoids, which is a category of hormones, and it contains a hormone called aldosterone, which is going to be our example in this class for mineralocorticoids. And aldosterone, it targets the kidney to regulate blood pressure and electrolytes like sodium and potassium. The middle layer, the zona fasciculata, produces glucocorticoids. One main one is cortisol. And cortisol plays a part in your long-term stress response. The internal layer, the zona reticularis, produces androgens, which serve as precursors to hormones such as testosterone and estrogen. These hormones, they influence secondary sexual characteristics, and they're usually converted into active sex hormones in other tissues. So androgens affect tissues depending on the specific sex hormone derived from them. Aldosterone is going to be important to us in this class. It really ensures hydration and electrolyte balance, what's called your osmolarity. And all of this, in turn, affects your blood volume and blood pressure. Cortisol, it can help your body cope with stress by providing like quick energy, controlling inflammation, and playing around with blood pressure too. And androgens, their main purpose is to support puberty and to maintain certain functions in adults by serving as an alternative source of sex hormones. Aldosterone, which we said is a mineralocorticoid, it regulates ions like sodium and potassium in the blood, but it does that by working on the kidney. It is released from the zona glomerulosa, right? So this here is aldosterone. And it targets the kidney because that's its effector. And what it makes the kidney do is conserve sodium and flush potassium or excrete potassium. And this action, it usually increases your blood volume and your blood pressure. Aldosterone release, though, is triggered by a couple different things. It can be triggered by low sodium levels. So if you're like well watered or overwatered, it can be triggered by high potassium levels, which we know are not good if you want to be having action potentials. And it can also be triggered by another hormone called ACTH, adrenal corticotropic hormone, which is released from the anterior pituitary gland. And strangely, it can also be regulated by renin, which comes from the kidney, which to me is like the kidney regulating itself. Anyway, aldosterone, it encourages the reabsorption of sodium, which means that it makes you keep sodium. That's what reabsorption means. And this also causes you to keep water, right? Because water follows salt. And so by keeping sodium, you're retaining a blood volume, you're also increasing your blood pressure. And this is why people are given salt tablets in hot environments, so they retain more water. And this is why you become bloated from salty foods like ham and pickled things. I'm sorry, I do love me like a Virginia ham on like Christmas or something like that, which is what my grandmother used to make. But I would wake up in the middle of the night like starving of dehydration, like, like, why am I so salty? But this is also why you or someone you know should eat some crackers before bed if you suspect that you're going to have a hangover. Because hangovers really, they're just a severe cause of dehydration. So aldosterone is also a really important in management of potassium. Your kidney prefers to get rid of potassium, and that's why potassium is kept quite low in your blood, so you can have those action potentials. But if potassium goes high, the adrenal cortex senses even just the littlest of increase, and it senses this humoral trigger, right? It's monitoring the blood, and it releases aldosterone according to this humoral trigger. Right? And then aldosterone, of course, then goes to the kidney and it makes it get rid of potassium even harder, even more than it did before. Cortisol should be your friend. It's not. It's not. Cortisol is a glucocorticoid released by the zona fasciculata. And it's regulated by the hypothalamus and the anterior pituitary gland through ACTH. And here's our cortisol here. And I know you're like, strange, Amy, this looks a lot like the previous slide. Yes, it does. So all of the physical effects that you suffer when you are stressed out at the end of the semester, all of them can be explained here by cortisol. So let's start at the bottom. These are white blood cells down at the bottom, neutrophils and basophils, it looks like. When you're under long-term stress, cortisol lowers your ability to make these cells, works on your bone marrow. And this results in a decreased ability for you to fight viruses and bacteria, and it makes you sick at the end of the semester. Bone and cartilage formation are depressed with cortisol, making stress management for young children really important. Growing up in a trauma state of violence, abuse, and or neglect can pump cortisol from the adrenal cortex full time. And this is probably why I'm like barely 5 feet tall. I am 5 feet tall. Anyway, in addition to managing potassium by way of the kidney, Cortisol, it also increases your blood sugar by stimulating glucose production in your liver and release of stored energy in adipose tissue. So at the end of the semester, students experiencing a wide range of digestive issues, from the first discovery of Crohn's disease, right, to simple heartburn. And this is cortisol at work. It's also working on your brain and your ability to concentrate. And this is why that last test, paper, quiz in all of your classes just seems impossible. It's cortisol at work. And this is why stress management, whether it be through deep breathing, which I hate it when people are like, breathe, just breathe. Whether it be through deep breathing, exercise, or any kind of therapy, stress management is very important at the end of the semester. My preferred methods are talk therapy and coloring. Coloring, as if that comes as any surprise to you.